Hi friends, have you ever thought how robots learn? Keep hearing about how smart AI is becoming day, but have you ever wondered how it really learns? Let's try to understand how robots learn like humans in this episode of engineering. Here we are with yet another interesting episode. Today we're going to talk about machine learning, which is basically teaching a robot to learn from its own mistakes. So instead of writing lines and lines of code for a robot to follow, we can just let it try and try again until it gets it right. It's not that simple. So without further ado, let's get started. Let's start with a very basic example so we can understand how it works. Say we have a robot arm and we want it to learn how to pick up a block from one place and move it to another. Usually what we would do is we would write a program for the robot arm to do exactly that. And if you're an experienced programmer, then you probably already know how complicated that can be because we need to take into account things like gravity, friction, the weight of the object itself, the exact position of the arm, and many more factors. But don't worry, we're not going to go into that. You can watch our previous videos on robotics to find out more. But needless to say, programming a robot to perform a task can be pretty difficult. Now imagine if we could just teach the robot to do all those calculations itself. That would be so much easier, right? And that's exactly what machine learning does. It allows the robot to learn from its own experience and improve its performance over time. But how exactly does it do that? Well, here's where things get interesting. Machine learning uses something called a cost function. A cost function is basically a way to measure the error of the robot's movement. In our case, we want the robot to move the block from point A to point B. So the cost function could be something like the distance between the block and point B divided by the distance between point A and point B. This gives us a value between 0 and 1, where 0 means the block is exactly at point B, and 1 means the block is still at point A, how we want. To find the set of parameters that will minimize this cost function and get the block from A to B as quickly as possible. To do this, we use something called gradient descent. Gradient descent is an optimization algorithm that finds the minimum of a function by taking small steps in the direction of the negative gradient. This doesn't make any sense to you, don't worry. All you need to know is that it's a way to find the best set of parameters for our robot arm. How does this work in practice? Well, we start by giving the robot arm some initial parameters, then we let it move the block from point A to point B. Then we measure the error using the cost function and see how far away the block is from point B next. We use gradient descent to update the parameters of the robot arm in the direction that will minimize the cost function. Repeat this process over and over again until the block reaches point B, and we get a cost function value of 0. There's a catch. We can't just keep repeating this process forever because we don't have infinite time and resources, so we need to stop at some point. Question is, how do we know when to stop? Well, this is where the concept of epochs comes in. Epoch is basically the number of times we run through the entire training process. In our case, an epoch would be one complete movement of the robot arm from point A to point B. We decide how many epochs we want the training to go through before we start. For example, we might set a target cost function value of 0.01, meaning that we want the block to be within 1% distance of point B after each epoch. Once the training is finished, we can check the value of the cost function to see how well the robot arm learned. If the cost function is less than 0.01, then we consider the training to be successful and we're done. This is a very basic example of how machine learning works, but it illustrates some important concepts that are used in more complex applications. One of the key ideas is that the robot learns from its own experience and feedback. By measuring the error at each step and adjusting the parameters accordingly, the robot is able to improve its performance over time. Another important concept is the use of an objective function or cost function to evaluate the performance of the robot. By minimizing the cost function, the robot is able to find the optimal set of parameters that achieve the desired behavior. Now let's move on to a slightly more complex example. So far we've seen how a robot can learn to perform a simple task like moving a block from one point to another. But what about more complex tasks like playing a video game? How do robots learn to play games like chess or Go? It's the same idea. We use machine learning algorithms to train the robot to play the game. The robot starts by taking random actions and observing the results. Over time, it learns to make better decisions based on the feedback it receives. One of the most popular algorithms used for training robots to play games is called Q-learning. Q-learning is a reinforcement learning algorithm that learns an optimal policy for an agent to follow in an environment. It does this by estimating the expected future reward for taking an action in a given state. The agent starts by taking a random action and observes the next state and the corresponding reward. It updates its estimate of the expected future reward for that action in that state and stores it in a table called the Q table. The agent then takes the action with the highest estimated reward and observes the next state and reward. It repeats this process until it reaches a terminal state, at which point it ends the episode and begins a new one. The agent continues to learn by updating the Q table and improving its policy over time. For example, in a game like chess or Go, the agent can learn which moves are more likely to lead to a win by observing the results of its own games and the games of other players. It can also learn to recognize patterns and make strategic decisions based on the feedback it receives. This is how robots can become masters at games that require complex decision-making and strategic thinking. Another interesting application of machine learning in robotics is computer vision. Computer vision is the ability of a robot to interpret visual information like images and videos. It's a challenging task because it requires the robot to understand the meaning of what it sees, which is something that humans do effortlessly. But with machine learning, robots are now able to perform tasks that require computer vision, such as object recognition, image classification, and scene understanding. For example, a robot with computer vision can be taught to recognize different types of objects by showing it a labeled set of images. The robot can then use this knowledge to classify new images and identify the objects in them. This has applications in manufacturing, where robots are used to inspect products for defects, or in healthcare, where robots are used to assist with surgery. Overall, machine learning is transforming the field of robotics by enabling robots to learn from their own experience and feedback. This is leading to robots that are more adaptable, efficient, and capable of performing complex tasks. As machine learning algorithms continue to improve, we can expect to see robots that can perform tasks that were previously thought to require human intelligence, such as natural language processing and autonomous driving. That's all for today. We hope you enjoyed this episode and learned something new about how robots learn like humans. If you like this video, please don't forget to hit the thumbs up button below the video and subscribe to our channel to get notified when we upload new videos. Also, if you have a topic that you would like us to cover in a future episode, please leave a comment below. Thanks for watching, and we'll see you in the next episode.